So, speaking of cruises, back on board. Aaron here is a prominent member of the Viennese Ruby community.
This guy.
He's about to tell us a little bit about plundering and thievery. Is the talk up? Yeah. And so, Aaron here has been a chef, a goat and sheep herder.
Wait, sorry?
A goat and sheep herder.
Sure.
Not herter. Herder.
Does our code of conduct include animals? Anyway.
And he once, was it last year or the year before, taught Mats on stage how to do a burpee. Do you know what a burpee is, Arno?
Do I look like I know what a burpee is? What is a burpee? So, does this come from here?
Maybe we should ask Mats what a burpee.
Mats, do you want to tell us what a burpee is?
No, but who do we have on stage? Aaron, what is a burpee?
It might come up in the talk.
Then you'll see.
In case it doesn't?
You want to do one? I need a partner to do one with if we're going to do a burpee on stage.
Arno, I've already done it. You should.
Is he lying?
No. Do it.
Wow, this is happening right now, isn't it? I haven't done them in a while, but you kind of squat down, and then you jump into a push-up position, like this, and then you go into a push-up and up, you jump back, you go like that, and you jump up like that, and and you do that over and over again, like 20 or 30 or 100 times or 500 times or whatever. I do it like 600 times. But that's a burpee.
So take it away, Aaron.
Thank you. Yeah, so that's up there now. So before I start the talk, it's pretty cool that we have a live feed right now, which means that my mom is watching from home right now. So, yeah. So, could we all at the count of 3? Could we all say hi, Debbie? Debbie, 1, 2, 3. Hi, Debbie. Awesome. Hi, Mom. So there's some weird stuff happening here with the slide, but we're just going to go with it. So the talk is called Steal This Talk, but I think I need to change the title. I'm changing it to The New Programming is a Manjanine. And this is a joke that you'll understand later. It's not funny right now, so it probably shouldn't have led with it, but it will make sense probably. So what's happening? Yeah, so something is weird with the slides. Can I... There we go, perfect. Okay, so I'm from the States. This is actually how we dress there. Don't trust the television shows that you watch. It's really every day. But I've been living for the last decade or so in Austria. This is me when I was, I think, 3 or some age. My mom, who's watching, probably knows how old I was. And it's kind of a bit of foreshadowing for my life right now. I have worn lederhosen. I have friends who wear them quite often, sitting in the front row. And around 2013, 2012, I was living in a tiny town in Spain that was in the mountains. There was like 2,000 people there. And I was programming, and I couldn't meet any other nerds. I met one nerd, but he was a medieval furniture building nerd. And it's kind of the opposite spectrum of software development and medieval furniture building. So I would go to conferences, and I'd go to JavaScript conferences in Spain, and being in Europe, I could go further to Europe. So I went to, my first Ruby conference I went to was EuRuKo in 2013, and I got there at 4 in the morning or something, and I was so tired that I had to stand for the whole first day, otherwise I would have fallen asleep. And it was great. Like the community, it was really, there was something special about it. Like I liked almost all of the talks too, which wasn't the case with any of the JavaScript conferences I've been to. I also met one of my closest friends right now at that conference, and that was awesome. And yeah, so I decided that at some time around there that I wanted to start speaking at conferences. I wanted to travel mostly. I wanted to meet new people, go to new places. And the route that I went was by speaking at as many meetups as I possibly could. And if you're from Vienna or lived in Vienna for any time, you've probably seen like way too many of my talks. If you raise your hand if you've seen too many of my talks, there's we got quite we got quite a few of them. So it actually worked, and I got the guts to try and put proposals out there and speak at conferences, and I ended up getting what I wanted. I got to travel around the world. This was in the Philippines with Matt's there, and there's another Ruby hero, Nick, and I ran my first 5K on the side of a highway in India. And I went to Warsaw and hung out with Piotr and Toby, who are here. This is in Warsaw during Christmas. Beautiful stuff. Author of one of my favorite Ruby books, Everyday Things with Ruby and R. Went to a castle with him. Got to eat durian, which tastes like I think people taste like. Got to use my first toilet shower in Bali. Tel Aviv Beach, some of the best food I've ever eaten in the world, and got to kind of an Instagram-style selfie on the tallest building in the world. And what Ramon kind of brought up, which, probably my peak moment in definitely my programming career, maybe one of my life peak moments, besides my kids being born, was doing burpees on stage with Mats. He's very good at burpees, that's why. It's not for any other reason. And then later, with Koichi. I mean, it's pretty blurry. I could say that's anyone, but it's Koichi later. So this was like I was living high. I was in, like, it was amazing. It was exactly what I was looking for. But then 2018 happened, and I just couldn't come up with any talk ideas anymore. I couldn't, like, I don't know. I thought I was solving interesting problems, but maybe I wasn't. I would give talks, and after the talks, I would just be depressed for like a week afterward, and I decided that I wasn't going to give any talks anymore. And the reason like this sucked the most, because I thought that there'd be no chance I'd ever get to exercise with Mats again. So jump ahead, let's go to sometime later last year, and I was watching YouTube, doing a little bit of looking around on the YouTube like one does, and I found this video where a guy generates a rap song using a recurrent neural network. And it's fantastic. There's like a hype man involved. He does things with changing the tempo and creating some really just crazy lyrics. And the AI actually gets really, really pretty deep at a certain point. It's very emotional. It's remember the fam and carry the pain. And I think that the machine being that deep is where the word deep learning came from. So I didn't know if that pun would work. I'm really, really happy that it did. Cool beans. So something clicked in my mind after watching that, and I was like, I can't come up with a good talk. AI, recurrent neural networks. What should I do? I know. I will create a recurrent neural network to write a talk for me. So it will create the title, it will create the description, and it will create the entire talk for me. So I went on a journey to, I built an application that could consume YouTube videos and then find the captions. It was kind of a cobbling of Elixir and Python binaries and stuff together. It's a horrible thing. I should open source it just so you can be so I want to talk a bit about recurrent neural networks, a phrase that I can't say for some reason. I have I can't say neural correctly. But the first thing that we'll have to talk about is a convolutional neural network, which was brought up yesterday in the closing keynote. So you have a little bit of an intro to it, and I'll go a little bit deeper. But first, I guess there's lots of firsts here. I want to do a little quiz. So I brought these wafery things from Austria. They're very Austrian. If anyone here is Austrian, can you tell me whether these are very Austrian or not? Okay, cool. I got a lot of yeses there. So I have some phrases, some titles, some talk titles up here, and one of them was generated by a recurrent neural network, and the other ones weren't. So if you raise your hand and you guess, you can pick this up later. No, so I see no hands so far, so we're still reading. There's one hand back there. That's the first hand I see. Which one do you think is generated? No. You can still have one of these though, so come find me afterward. You. Number 4. Correct. You get 2. You have to give one to one of your neighbors. We'll do it later. So yes, it's number 4, the impermanence of Ruby, which is a pretty cool talk title, actually. Something bad is happening. Not terrible, though, just something kind of, there we go, cool. So I'd like to kind of give some examples to get into kind of talking about what exactly a recurrent neural network is, some analogy sorts of things. So let's say you wanted to create a program that took in pictures and told you whether it was a windmill or it wasn't a windmill. So it would give you some sort of a yes or no answer out the other side. And I picked a windmill because, you got to pick windmills here, or bikes or something. So one way that you could do this, kind of the simplest way to do it, is to get every single object in the world and classify all of the features about that object. So chairs have legs, they have like rectangular back parts and a seat, and I should have considered more what objects would be on stage. A monitor is rectangular, has a screen, and some of these other wonderful things, a stand. And you could just take all of the objects in the world and take the image in and say, okay, does this image have, it has something that's like rectangles. It looks like, let's say we know that's a window. The shape of it is like a trapezoid shape. So cool. It has these kind of rectangles coming out from the sides. Great, awesome, we know that it has those. It has this cross in the middle. So it turns out that all of those features are all pretty much features of a windmill as well. So we can say with some level of confidence that this image is an image of a windmill. So we would say if it's 70%, if we're 70% confident, let's say yes, it's a windmill. So this is a windmill. The problem with this solution is that it's incredibly inefficient to categorize all objects in the world by little features of them. It doesn't make any sense. So let's take it kind of another step further, kind of try and do a little bit of abstraction. Say we have little kind of programs that can know a little bit more. So programs that can talk to other programs. So we have one program that knows about windows. So this says, yeah, I think this is a window. We have another program that says, hey, window program, is it a window? And then it also says, is there a trapezoid shape? And this could be our building program, let's say. So it says, yeah, maybe it's a building, it has a window, and it's a trapezoid shape. Then we have another one that says these shapes, these mean that it's blades. And then we have our last piece that's our windmill program that says if it's a building and it has blades, it's probably a windmill. So cool. So now we've normalized things. We don't have to have all of the classifications of all the things. Now we actually have categories of ideas of things. But I mean, the problem with this is that it's also incredibly inefficient to categorize all the things. And then you have the problem that new objects come into the world all the time. What you have to classify them, it's a nightmare. So what a neural network does is it randomly generates all of those categories for you. So you give it an input of numbers, and it takes those numbers and finds a way to make patterns out of them. Yeah, so for example, so this will look familiar from the last talk yesterday. I would, to simplify our situation, I would take my image and make it the resolution, bring it way down. So make it 32 by 32 pixels. Let's simplify it even more, getting rid of the color, so all we have is a grayscale. And now we have a pretty small, a reasonable input into our neural network. It's 32 by 32 pixels, or 1024 pixels. Each of the pixels has a grayscale value from 0 to 1, being 0 is white, 1 is black. And then we can feed each pixel as one node into the first layer of our neural network. So we have 1024 nodes, and we're feeding it into the network. Cool. So our network starts with one, like the input node, the input nodes, and then there's multiple layers, possibly multiple layers in between, and then we have our output node, which is this this yellow or this green one. Wow, my colorblind. And so what we would say in the end, we would okay, great, going through. I have this level of confidence in the end that this thing is a windmill coming out the other side. There's an idea of backpropagation. So all of these nodes are kind of connected together in a certain way, and their connections can be strengthened or weakened. What backpropagation does is it's the way your network learns by going back through, if you have if you have a picture of a windmill and it correctly guesses that's a windmill, you can go back through the line of nodes that created or that guessed that was correct, and you can improve or strengthen those ties, while if it's wrong, you can kind of weaken the ties of the connections that made the bad guess. So that's how it learns. It's constantly like going through and then doing backpropagation and making good things good and bad things worse. We have a different kind of problem than image recognition. We have a problem where we're trying to generate new words based on a bunch of other words. So you need a slightly different tool to solve this problem. And there's lots of different kinds of neural networks. You can start with, there's something called a Perceptron, which I think one example could be you have a bunch of data points, like you have reservations at your restaurant, and you can look at the reservations per night and then the amount of maybe salmon pieces that you need to prepare. You could graph those on an XY axis and then try and find a line that kind of goes through. I'm doing this backward for try and find a line that goes through, and then hopefully in the future what you could do is look at how many reservations you have tonight and then find out where that line is that meets, and you can predict, oh, maybe I need 23 salmons prepared today. So that's the very simple version up into these networks of different things with memory and state and all kinds of things. So a convolutional neural network is great for images, like we just saw, but recurrent neural networks are great for text generation and for voice recognition because they have this added feature of having memory. So if I give you a line of text, a recurrent neural network can know about what it's seen in the past. There's a bunch of state machines, and they hold kind of a history of what has happened in the past. So for example, I have the word good, and I want to predict a word that should come after good. Let's pretend that I've never seen good before. If I pick the word food, that could be a sentence that makes sense. If I pick the word run, like I went on a good run, that's a sentence that makes sense. If I pick bad, pretty much you can say that almost never does a word bad come after the word good in a normal sentence. So in a recurrent neural network, you can know about the past to help you make decisions about the future. So this is one place that it would be good to use it. They have memory, as in state machines. You train them by taking an input set of things that you know about. So I would take for this text, I would take a bunch of text that is similar to the text that I want to generate. And then it knows in the end what was generated before. So if it makes a prediction about the next character or the next word, it can look at what I gave it and know if it picked the right next word or not. And then it should be able to do that by itself after you train it enough. The way that you make it smarter is by reducing something called a loss function. And I'll try to explain that right now. So if I'm trying to guess the next character in a series of characters, like should it be an A or a B or a C or a D next in this word, my neural network might come up with a guess that it's probably not A, B, more likely to be B. It's probably B. C is an okay chance, and D, there's no way. So what you do is you take the guesses, the guesses from your neural network. You take the actual thing from your training data. In this case, the next letter was actually a B. You subtract the guesses that you had from the actual, and then you get something like plus or minus numbers. But we're going to add these together, so we want to get them all to the same sign. The way that's done is by squaring them. So we have all of these numbers. We add them together. We end up with our loss value. And the point of this loss value is to try and move it towards 0 as much as possible. I've found that for the libraries that I'm using, that getting it, for my small data set, getting it around 1 is pretty good. And yeah, so this is our loss. And the goal, you just want to keep reducing this loss, and each time you're training, your neural network is trying to find a way to reduce that loss function or getting closer to guessing the right thing. So here is an example of it actually running, and this is the loss in the beginning while I'm feeding it the data set. So I think this is like hundreds of Ruby talks. and the loss is going down. And you can see this is the second sample, or this is the second time it runs the sample through. The loss is going down even more. It should eventually get toward 1. And what that kind of looks like is you have all of your nodes have a different weight. And what you can think of a weight is like a volume knob on it. And each time it's trained, it changes the knobs and moves the numbers up and down a little bit, and then looks at the results and sees if the results have reduced the loss or increased it. And it uses calculus to try and decide kind of what the next minimum, the local minimum is of like a graph that could have many different, dimensions. That's the word I was looking for. Yeah, so it goes through, it messes with the numbers, it switches them around a bit, and then it starts to learn. So in the beginning, it's taking guesses. It's trying to get used to kind of like what is a word, like what is a space, how do these things look together? And with the library that I'm using here, there's an idea of volume, and the higher the volume with this, the more the neural network tries to be creative and come up with new kind of ideas. You can see that this is the first run through, and it just is like letters. And then you you turn up the temperature, it's more creative, and you get things like awam. And then when it's more creative, it's just schnarkadishnamava. And it continues to go on, and you can see that the loss is going down. And then in the next, it should start to kind of know more about common words and things and edges of sentences. So we have lots of thes and ands, and we have the word whys. I guess people maybe say that a lot when they're doing Ruby talks. And then you can see it's more creative, and then when it's really creative, it's just still absolute nonsense. And the bigger your training set is, the more you reduce your loss, the more the creative side actually gets to be kind of this wacky sort of, sometimes, whoa, that's deep sort of thing happening. And now you can see that there's actually it creates new words like program and programment, which is fun. And yeah, so that's generally like the learning process. It keeps going through the data set over and over again. I don't think I have time for a second quiz actually, but I'm gonna do it anyway. Sorry, buddy. Anyone? You can't do it. Anyone? Huh? There's one. Yeah? 4. No. 1? Yes. You got to come later. You get 2? We get 2? You get 1 for saying the wrong one, too. I don't even know what's happening here. Actually, this is a trick question. The second one is also auto-generated. But I love the imposter approach. That's it's a great talk title. So I have to do this actually really fast. I'm very sorry. One of the things that the application that I built did was create RSS feeds of downloaded the audio from the YouTube talks, and then created an RSS feed for a podcast stream, which I then listened to a bunch of Ruby talks at 3 times speed. So I'm like a master Rubyist now. That's how you do it if you want to proceed to the next level. So I'm going to try and tell you some tips from some talks that I learned from doing it. The first tip is that Ruby is dead. They were going too fast, so I don't know if this was sarcastic or not. It probably was. So the rules it's a great talk from Sandy Metz, and she came up, first she described where rules come from, self-interest, authority, like the government, out of habit, like you just create rules because you're used to doing things a certain way. But she has 5 rules that are pretty Rails related that she put forward that we should follow. And I think that they're pretty good places to start. One is that you should only have 100 lines per class. One is that you should only have 5 lines per method. 4 parameters per method. So some, yeah. 1 instance variable per Rails view. But I'm sure you're all building single page applications with Redux and React and Apollo and GraphQL and all of the cool tools. So you don't have to worry about this one. And then 2 class names per action controller action, which she refers to as being like a presenter class and like a command or an interactor or some kind of a object-oriented sort of thing. Yeah, I'm good at words. So during this talk, after this talk, a guy at the conference actually created a gem that's a static analyzer for your code for the Sandy meter, and then he gave a lightning talk, and it was pretty great. And the other amazing thing to come out of this talk is this. It's a remix of the talk. It's really, yeah, so this is, you can find this on SoundCloud. I'm serious, like you really can. So I'm going to do this even quicker, I think. So these are all performance wins. This is from multiple talks kind of combined into one, that they're things that you don't really have to make your code uglier, but you can still get benefits from having way faster code. I actually did the benchmarks on most of these, so when it says 4 times, it was Ruby 2.5.5 on this computer. So yield is 5 times faster than using block as an argument. So then calling block.call within the method, 5 times faster. This guy over here. So the symbol to proc, the first one that I show is faster than doing the block. I think that it's like 2 times faster maybe. Flat map is faster than map.flatten, which is great because when you know about flat map and you need to use that, it's a great tool for the solution. Delete prefix, delete suffix, 5 times faster than sub. It's crazy if you need that. Sub is much faster than gsub. It's around 2 times faster. So if you can reach for sub, do it. String.squeeze is about 40 times faster than gsub. 40 times faster. So if you're trying to remove white space, it's great, but there are a couple of caveats with this. So be careful. Make sure you know the things that you're replacing. Hash.dig is 2.5 times fast. I actually learned this recently, that's a thing. I love it. And so then kind of digging into it, and it's 2 times faster than using hash.fetch with a fallback block. Of course, if you need to raise an exception, hash.fetch is wonderful. I think this is like 4 times faster or something like that. It's just using the symbol instead of using the toProc, and it's cleaner maybe. I don't know. What do you think? So. Good, I got through that. I'm only just slightly over time. You probably want to know how my AI, my network of intelligence turned out. So my new talk that I'm starting this year is called Keeping Leaders Debugging Rails 5. It's by me. So the description is, the Mile Island Test Things is a company by the leader. In this talk, we'll look at the world of the world, to technical company who have strategies that we can do through the most productive, to the company who communicate, the code that we can do to communicate the first production of the CodePon. So that's great, but what I'd rather do is not actually have to give the talk myself. So I found this tool on the internet where you can record a bunch of samples of your voice, and it will then create an audio avatar for you, which is a bit creepy right now. There'll probably be some deep fakes about me soon, but I kind of want to get like a Tupac hologram. This is a hologram of Tupac talking. That's Snoop Dogg over there. It'll be less creepy because I'm still alive. Here's the talk.
The big thing that we can think of the things or experience with a company into the same test. You know that with the best to go through the time that's the ordering. So the problem is that if you don't want to use very simple view, then we start to think it could be able to get a lot of things. We can do with this, but it's a bit of math, which we do this is that the things that probably come from the scope of it. The sense in the software to the client and the team and the selfish programmer, then this is the first job.
Don't be a selfish programmer.
The things I would like to do this problem that we're doing, and there's a lot of these values. Down to 60,000 classes or something like that. It's not the graph of UDB as a function that we want.
It's a lot of classes.
To be good for the operation, the text that actually makes it sort the string of the backend. It is the source controllers, and the thing is the same part of your data state, and then it is all the code. Because I have the scope of the model and the same time to do. And the second is, we can use like this, is what I can look at like a super project.
And in the end, what we're really looking for, I think, is a super project. So I submitted this talk to DECON RubyConf recently, so we'll see. Maybe you'll be seeing this talk in 2018 or 2019, or 2018. So Thank you. It's been wonderful. It's really like an honor to be on this stage after following this conference for so long and volunteering last year. Like, I love it. Thank you.
Wow. Aaron, thank you so much.
Thank you.
Little bit of pirate treasure for you.
Awesome. Thank you.